Let's take a look at an example here before we really move on. And what we want to do is we want to go ahead and take a look at the area of a function. And so let's consider the function y is equal to 1/2 x cubed. Y equals 1/2 x cubed. Now in this case, we're going to check out x equals 2, or centered around 2. And the change of x is the same as the differential of x, and that's equal to 0.1. Okay, and so let's compare. We're going to look at change of y and dy and see how they compare and see how good of an approximation this is. All right, well, the change of y, recall, the change of y is equal to, and we can run up here and remind ourselves of what it is. The change of y is f of c plus delta x minus f of c. So this is x equals 2, and the change in x is 0.1. So this is going to be f of, and this is 2 plus 0.1 minus f of 2. Now f of 2 cubed is 8. Whoops, I should probably do this in order. 2.1 cubed, and so this is 1/2 of 2.1 cubed minus, having a hard time today reading my own writing, minus 1/2 of 2 cubed. And so I'm just going to bring up my other calculator here, and I say 0.5, whoops, turn it on, 0.5 times 2.1 cubed equals 4.365. This will be 4.365. Oops, 361, sorry, my bad. 361. I'm still getting that wrong, aren't I? 631. Man. 4.631. 4.631 minus, and now this is going to be 8, and 1/2 of that is 4, and so this is 0.631. So delta y is 0.631. Okay, now dy is equal to the derivative at x with respect to x and times the differential value. That means that this is equal to, now the derivative of this, we have to find the derivative. And so y prime in this case is 3/2 x squared. And so this is going to be 3/2 times x squared was 2 squared times 0.1 equals. Okay, so now we want to take 3 divided by 2 times 2 squared, and we want to multiply that by 0.1. That's 0.6, 0.6. And so that's not too bad. Look, the difference between, and so if we look at the difference of delta y, which is the change in y, and the differential of y, or dy, is 0.031. Well, that's not bad at all. And so it just depends on how tight you want this. Now in automotive engineering, this is 31 thousandths of an inch. You're talking about the separation between the cylinder walls and your piston being something on the order of 1/10,000th of an inch. So you can see that you have to tweak this just a little bit. So you have to make your differential just a little bit smaller in order to really squeak this by. And in this next video, we'll be taking a look at just how they managed to do that.